Hey guys, so this is your first geometry lesson, and we're actually not going to start with geometry. We are going to do an algebra review. I just feel like last year algebra got cut short, obviously, because of all this coronavirus stuff. And so we had to go to distance learning, and we weren't able to do a lot of things that we actually do in Algebra 1. And those are skills that you really need to know how to do, especially when you start taking like your ACT and TSI and all of that. So let's start, and this unit is not going to be unit 1. I want you to write R1 for review 1, and the title of this will just be Algebra Review. And the first lesson will be R1.1. And the page title is Adding and Subtracting Polynomials. I wrapped too big, so I'll have to squeeze it over here. Okay, so let's go ahead and turn to the first notes page. In the activity you just did, you had to sort different types of polynomials, and you may not have known it or not, but now you do. You can separate polynomials by the number of terms that they have. So let's start off with these two definitions. The first one is an algebraic expression, which is a generalization that is a combination of variables, numbers, constants and coefficients, and operators. I know that sounds super confusing, but it's really not too bad. Remember, variables are just letters like X, Y, Z, numbers, and then operators are like multiplication, division, addition, and subtraction signs. So an algebraic expression could be a polynomial, and the definition of a polynomial is a monomial or the sum of monomials. So let's take a look at the different polynomials that you just looked at in the activity. The first polynomial is called a monomial. And the root word of that is mono, which means one. So the definition of a monomial is just a one-term polynomial. And what we mean by one term is that all of the numbers and variables are being multiplied together. So it's just one term all together. The next type of polynomial is a binomial. And the root word of that is bi, which means two, like a bicycle has two wheels. So a binomial has two terms. And we can see in this example that this is two terms. The first term is 4x squared, and the second term would be negative 9x. So now I'm separating these two terms by a minus sign. Let's move on to trinomials. The root word of that is, or the prefix is tri. So a tricycle has three wheels, so a trinomial has three terms. In this example, my first term is 2x cubed, then negative 3x squared, and then positive 2. So because I'm separating the first term with the minus sign and the second term with the plus sign, I have three separate terms. I'm not multiplying everything together like in a monomial. I have the separation with addition and subtraction to create these three separate terms. Okay, so let's talk about the degree of polynomials. The degree of a term is the sum of the powers on the variables in the term. So when we're talking about powers and degrees, we're really just referring to the exponents. And if there's more than one variable in a term, you have to add the sum of the powers on those variables. And then the degree of a polynomial is the same as the degree of a term in the polynomial, but we're looking at the highest degree, and that would determine the degree of the whole thing. So let's look at these examples. Go ahead and mark out this middle section. Let's start with -5. So -5 is just a number. There's no variables. And since there's no variables at all, the degree would just be 0. But in the next example, we have two separate terms, a 3x and an 8. Since the x is a variable and it's raised to the first power, remember there's like an imaginary 1 here. This is really x to the 1. The degree of this polynomial would be 1. In the next example, all of this is one term, but I have two separate variables. I have an x and a y. So go back to the definition of the degree of a term, and we have to add the powers together. So I have a power of 3 on the x and a power of 2 on the y. So I would add those two together, and the degree of the entire term would be 5. You only do that if you have more than one variable in a term. Okay, the next example, 4x squared minus 9x. So my first term is 4x squared, and my last term is -9x. I need to determine what's the highest degree of each term. So the first term has a degree of 2 because it's x squared, and the last term has a degree of 1 because it's x to the first power, or x to the 1. So since 2 is greater than 1, the degree of the polynomial would be 2. And then this last example, I have 2x to the 4th minus 3x cubed plus 5x. So I need to find the highest degree, or the highest exponent of each term. I have an x to the 4th, an x cubed, and then an x. So the highest degree would just be 4, since that's my highest exponent in each term, or of that term. Okay, something to keep in mind is always write polynomials in order from highest to lowest degree. So maybe you have a polynomial that looks like this, x plus 2x cubed minus 4x squared. We need to write this in correct order. So I want my highest degree first, which would be the x cubed. So I would rewrite this as 2x cubed. And then my next degree would be x squared. So this would be minus 4x squared. And then finally the x. So as you can see, the exponents go in order from highest to lowest. So we just want to make sure that we always do that whenever we're writing our polynomials. Let's move on to the next page now. So for this lesson, we're going to be simplifying polynomials by adding or subtracting them. The first step is to clear grouping symbols using the handy-dandy distributive property. See if I can squeeze all that on there. And then you're going to combine like terms. And finally, we're going to make sure that whenever we write the polynomial out, we need to place terms in order from highest to lowest degree and alphabetical. So remember that degree just means exponent, so you always want to start with the highest exponent and then work your way down. Okay, so let's start with this first example. I have -3 times 3x plus 5 plus 2 times 9x minus 6. So I need to start off with distributing out this -3. So -3 times 3x is -9x, and -3 times 5 is -15. Now we need to move to the other side. I need to distribute out this +2 to each term in this parenthesis. So I have 2 times 9x, which would be 18x, And then 2 times negative 6 is negative 12. So we just did the first step. We cleared all of the grouping symbols using the distributive property. Now we don't have any parentheses left, and so we can move on to just combining like terms. So we need to start with the x's, and I need to add negative 9x plus 18x. So negative 9 plus 18 would be 9. So I would get 9x. Then combine your numbers. So I just have negative 15 plus negative 12. So negative 15 minus 12 would be negative 27. So my final answer would be 9x minus 27, and that is in the correct order. Okay, let's move on to this next example. We've got A's and B's going on here. So I need to distribute out this 5 to each, the A and the B. 5 times A is 5A, and then 5 times negative B is negative 5B. And then we're going to move to the negative 6. So I need to multiply or distribute out the negative 6 to the A and the B. Negative 6 times A is negative 6A, and negative 6 times B would be negative 6B. Let me rewrite that real quick so it looks more like a 6. There we go. Okay, so now we've done the first step. Now let's move on to combining our like terms. And since I don't have any degrees here, I just need to stay in alphabetical order. So let's start with the A's first. So I have 5A minus 6A. 5 minus 6 is negative 1, so I would have negative 1A, or just negative A. Now let's go to the B's. Negative 5B minus 6B. Negative 5 minus 6 is negative 11, so I would have negative 11B. Alright, let's do one with fractions. I know y'all are just so excited. All of you love fractions so much. Okay, so let's distribute the negative 1/2 to each term in the parentheses. So we're just going to take half of these numbers and make them negative. So negative 1/2 times 4 would be negative 2x. And then negative 1/2 times 2 is negative 1. Now let's distribute out the 5/3. So 5/3 of 9. Here's a little trick for this. Remember, whenever you're multiplying fractions, you just multiply straight across. Okay? So really when I multiply 5/3 times 9, I can really multiply it by 9 over 1. So this would just be 45 over 3 if I multiply straight across. And 45 divided by 3 is 15. So 5/3 times 9 would be 15x squared. Then I need to multiply 5/3 times negative 6. And same thing, if I want to multiply this fraction, I'll just multiply straight across. So 5 times 6 would be 30 divided by 3. And 30 divided by 3 is 10. Okay, but remember this is negative, so this would be negative 10x. And then the last one, 5/3 times 3 would become 15 over 3. And 15 divided by 3 is 5. See, that wasn't too bad. Also, if you don't like doing that in your head, which I encourage you to do, because you need to still remember how to multiply fractions without a calculator. But if you need to check yourself, go ahead and type it in and make sure that you did it correctly. Okay, so now let's combine like terms and make sure we write this in order from highest to lowest degree. So my highest degree would be x squared. So I need to start with this negative 15x squared. And that's my only one, so I'm just going to write it first. Now let's move to the x's. Negative 2x minus 10x. Negative 2 minus 10 is negative 12x. And then I just have this plus 5 at the end. So I would get negative 15x squared minus 12x plus 5. Alright, so now let's do this application problem. So we have a rectangle. Go ahead and draw a rectangle that has a length of 4m squared plus 6mn. And a width of 6mn minus 3m squared. And we want to find the expression for the perimeter of this rectangle. So remember, perimeter is when you add up all of the sides. So if this is a rectangle, then I know that the opposite side, or the side that's parallel to it, should be the exact same. So over here should also be 4m squared plus 6mn. And then down here should be 6mn minus 3m squared. So now we're just going to add them all up. Let's start with the m squareds because it has the highest degree. So I have 4m squared minus 3m squared plus 4m squared minus 3m squared. So basically 4 minus 3 is 1, 1 plus 4 is 5, and then 5 minus 3 would be 2. So I would have 2m squareds. Now let's go to the mn's. 6mn plus 6mn plus 6mn plus 6mn. So I have 6 plus 6 plus 6 plus 6. So that would give me 24 mn's. So my final answer would be 2m squared plus 24 mn. So that's it for the notes, and we're going to move to your practice problem. Remember that this worksheet is due on Friday. If you have any questions, you can call or text me at any time, preferably not like at midnight or 2 in the morning, but I'll try my best to help you with any questions. You can text me your problems or call or email or whatever, and I will help you. Hope you guys have a great day, and I'll talk to you soon. Bye.